In 2009, an electrical engineer named Paul Sievert was hired by the Coast Guard to assess the condition of the electrical infrastructure at a lighthouse in Maine. One of the original argan lamp installations, built in 1831, converted to electricity in 1911, and still operating as an active aid to navigation. Sievert's job was to assess whether the wiring from the 1911 electrification was still serviceable or needed replacement. He brought a spectrum analyzer, which is a standard piece of diagnostic equipment that reads the electromagnetic environment around electrical systems. What frequencies are present in the air and in the wiring? At what amplitudes? From what sources? He used it to characterize the electrical environment around the lighthouse before he started work, as he always did, and what his analyzer showed him was a frequency he did not recognize. Not a radio frequency, not a standard power line frequency. Something in a range he could not immediately identify, coming from within the stone structure of the lighthouse itself, present in the air around the lamp room and diminishing as he moved down the tower and outside. He noted it in his field log, finished his assessment, submitted his report, which did not mention the frequency because it was not relevant to the wiring question he had been asked, and moved on. He would have forgotten it entirely, he told me, except that 8 months later he was hired to assess a different lighthouse, built in 1847, in Connecticut. His analyzer showed the same frequency. He told me about this in 2019, 10 years after the Maine lighthouse and 9 years after the Connecticut one. By that point, he had worked on 14 pre-1850 lighthouses on the New England and Mid-Atlantic coast, and his analyzer had shown him the same frequency at every one of them. Not an approximately similar frequency. Not a range. The same frequency to within the measurement resolution of his equipment at 14 structures built in different years, by different contractors, in different states, from different materials. He had also worked on 11 lighthouses built after 1870, on the same coastline, with similar construction and similar histories of electrification. His analyzer had not shown him that frequency at any of those 11. The pre-1850 structures had it. The post-1870 structures did not. He did not know what it was or where it came from. He had not, in 10 years, found anyone who could tell him. And he kept his field logs because he could not explain what he was logging. I came to this through a working group. There is a small, informal network of historical lighthouse preservation engineers in the northeastern United States. People who work on these structures regularly enough to have developed both expertise in their peculiarities and a culture of sharing observations that don't fit the standard maintenance literature. I had been corresponding with this group for a different project when someone mentioned Sievert's name and the frequency. I asked to see the field logs. He sent them. I spent 3 months with the logs and with the existing literature on 19th century lighthouse construction and on the electromagnetic properties of the stone types used in pre-1850 American lighthouses, before I understood that the frequency Sievert's analyzer was reading was not in any of that literature. It was not in any literature I found at all. By the time you reach the end of what I am going to tell you, you will understand that the frequency Paul Sievert found in 14 pre-1850 lighthouses is not an artifact of the granite, not a residual effect of the original argan oil lamp mechanisms, and not a byproduct of the electrification work done at these structures in the early 20th century. The frequency is present in the stone, in a pattern that corresponds to the construction specifications used by a specific group of lighthouse builders active in New England between 1820 and 1848. And it is present today in active navigational structures that the Coast Guard maintains, at the same value it showed Paul Sievert's analyzer in 2009. The question of where it comes from has an answer I have traced as far as a letter in a sealed estate archive in Providence, Rhode Island, written in 1849 by the last supervising engineer of the pre-1850 construction program. And that answer is not one I expected when I started following this. Consider what American lighthouse construction was in the period between 1820 and 1850. Because most people picture lighthouse building as a straightforward engineering problem. Put a light on a rock, make the structure tall enough and strong enough to survive storms, and the pre-1850 American program was considerably more deliberate than that picture suggests. The fifth auditor of the Treasury, a man named Stephen Pleasanton, administered the American lighthouse system from 1820 to 1852. And his administration was characterized by an extreme conservatism in construction specifications that his critics, and by 1850, he had many critics, including the engineer I.W.P. Lewis, whose 1843 report to Congress described the American lighthouse system as technically inferior to the European standard, attributed to cost-cutting and bureaucratic inflexibility. Pleasanton specified particular stone types for lighthouse construction, particular mortar formulations, particular construction sequences that his contracts required contractors to follow. These specifications were unusual enough that they drew comment from the contractors who had to follow them, and from the engineers who examined the finished structures. The unusual element was not the strength of the specifications. They were standard for masonry of that era, but their precision in areas that did not obviously bear on the structure's function as a lighthouse. The mortar formulation, in particular, was specified to a degree of chemical detail that the contractors found unnecessary, and that Pleasanton refused to relax despite repeated requests from the field. Lewis's 1843 report to Congress is the most detailed contemporary critique of the Pleasanton program, and it is worth pausing on what Lewis actually criticized, because the standard summary that Pleasanton's lighthouses were inferior to European standards obscures the more specific complaint. Lewis did not argue that the structures were poorly built. He argued that they were built to specifications that served purposes he could not identify. His report includes a section describing his inspection of the mortar formulation requirements in Pleasanton's contracts, and his conclusion that the chemical specifications exceeded what any structural or weatherproofing purpose would require. He writes that the specifications call for mineral ratios that have no precedent in the masonry literature he has consulted, and that the contractors to whom he spoke found inexplicable given the structural requirements of the work. He does not speculate about what purpose the specifications might serve. He notes the excess precision and moves on. This passage in Lewis's report is cited in the standard histories of the American lighthouse system as evidence of Pleasanton's bureaucratic rigidity. I now read it differently. Lewis noticed the same thing Stroud noticed 180 years later. He didn't have a spectrum analyzer. He didn't have the concept of piezoelectricity. He noticed that something was specified with a precision that the stated purpose didn't require. And he wrote it down, and it has been in the congressional record since 1843, filed under Lighthouse administration, waiting for someone to read it next to a materials analysis. The mortar formulation is dataset A. And this is where the second body of evidence enters, because Paul Sievert is not a materials scientist and would not have known to look at the mortar. I brought in a materials analyst named Raymond Stroud, who has spent 30 years working on historic masonry, and asked him to take samples from 3 of the lighthouses in Sievert's field log, 2 pre-1850 structures, and 1 post-1870 structure for comparison. Stroud's analysis produced results that neither of us had anticipated. The mortar in the pre-1850 structures is not unusual in its mechanical properties. It is unusually consistent in its mineral composition, specifically in its silica content, and in the ratios of certain trace minerals present in quantities that Stroud described as too precise to be attributable to natural variation in the source materials. Someone had specified those ratios with a precision that exceeded anything the standard masonry literature of the 1820s through 1840s called for. And those mineral ratios, in the combination and proportions Stroud found, are consistent with Stroud's language, not mine, piezoelectric properties that would be enhanced by the cyclic mechanical loading the lighthouse structures experience from wind and wave action. Piezoelectric, the word describes a property of certain crystalline materials that, when subjected to mechanical stress, generate an electrical charge. It is the principle behind the spark mechanism in a gas lighter, behind the transducer in an ultrasonic cleaner, behind certain types of sonar equipment. It is not exotic physics. It is well understood. What is not well understood, what Stroud had no framework for when he gave me his analysis, is why an 1820s mortar formulation would be specified with the mineral ratios required to enhance piezoelectric behavior in structures that are, by their nature, subject to constant mechanical stress from the ocean environment. Because piezoelectric behavior in a stressed structure generates a frequency, and the frequency it generates is a function of the material's composition and the geometry of the structure. And the material's composition in these 14 lighthouses was specified to a chemical precision that exceeded anything the era's masonry practice required. This is the part I keep returning to, because before I accepted the material analysis as the explanation for the frequency, I spent a considerable amount of time trying to explain it away through other means. The first innocent explanation I tested was the most obvious one, that the frequency is an artifact of the electrical systems installed in these lighthouses in the early 20th century, and that the pre-1850 structures simply share a common electrical contractor or a common equipment specification from the electrification era. I checked the electrification records for all 14 structures in Sievert's log. They were electrified by 4 different contractors over a period of 18 years, using equipment from 3 different manufacturers. There is no common electrical infrastructure. The frequency is not in the wiring. Sievert confirmed this directly. His analyzer showed the frequency in the stone of the lamp room, above the electrical infrastructure, at the same amplitude whether the electrical systems were live or shut down for the assessment. The second explanation I tested was geological, that the granite formations underlying these lighthouse sites share a mineral composition that produces the frequency through natural piezoelectric behavior in the bedrock, and that the lighthouses simply happen to be built on similar rock. I pulled the geological survey records for the 14 sites. The bedrock formations are not similar. 4 of the 14 are built on granite, 3 on basalt, 4 on schist, 3 on mixed formations. The frequency is consistent across all 14 regardless of the bedrock. It is not coming from beneath the structures. It is in the structures themselves, in the construction materials, and most specifically, as Stroud's analysis makes clear, in the mortar. This is the part I keep returning to, because I put Sievert's frequency measurements next to Stroud's material analysis and next to the Pleasanton construction specifications, and something happened that I have not been able to explain away in 5 years of trying. The frequency Sievert's analyzer reads at these structures is within the measurement resolution available, consistent with what a materials physicist would calculate as the expected piezoelectric output frequency of a structure with Stroud's measured mineral ratios under the mechanical loading conditions of a coastal lighthouse environment. The frequency is not arbitrary. It is not a coincidence of construction materials. It is what you would calculate it should be if you had specified the material to produce it. And here is where I have to be precise about what I am not saying, because the temptation in this story is to run further than the evidence allows. I am not saying that Stephen Pleasanton understood piezoelectricity. The word was not coined until 1880, 30 years after his administration ended and 14 years after his death. I am not saying that whoever specified the mortar formulation had a theory of electromagnetic frequency generation. What I am saying is that the specification produced a result, and that the result is measurable today, and that the result is consistent across 14 structures in a way that cannot be attributed to coincidence, and that someone between 1820 and 1848 specified a mortar formulation with mineral ratios precise enough to produce that result, whether or not they understood why those ratios would do what they do. The letter I mentioned, the letter in the estate archive in Providence, is the document that brings me as close as I have been able to get to whoever that someone was. The archive belongs to the estate of the Whitmore family, a Providence merchant family whose patriarch, James Whitmore, was the primary stone contractor for 11 of the 14 lighthouses in Sievert's field log. James Whitmore died in 1871, and his papers passed through the family line until they were deposited with a Providence law firm that has held them in sealed trust since 1953. When the last family member with a direct claim to them died without heirs and left the disposition of the estate to a legal process that is not yet concluded, I accessed a portion of the papers through a charitable foundation that has been working on the estate question and that permitted me to review selected business records. The letter I am describing was not in the business records I was permitted to review. It was described to me by the Foundation's archivist, who had read the full collection in the course of the estate process, who could not share it directly but who described its contents with a specificity I trust. The letter is dated November of 1849. It is written by a man identified in the archivist's description only as the supervising engineer, not named, addressed to Whitmore in his capacity as contractor, marked private. Its subject, according to the archivist's description, is the mortar specification for the lighthouse construction program. The supervising engineer writes that the specification has been followed correctly in the completed structures, and that the structures are performing as intended, by which he does not mean, the archivist emphasized this, as intended in terms of their function as lighthouses. He writes that the frequency the structures are generating is within the range specified and is consistent across the completed installations. He writes that the next administration, Pleasanton's term was already ending and his successor's appointment was anticipated, will not continue the program, and that the knowledge of what the specification was for should be preserved somewhere outside the official record, which is why he is writing to Whitmore directly. The letter describes the frequency. It describes the intended range. It does not describe the purpose. I am not in a position to tell you what the frequency is for. I want to be precise about that, as I have tried to be precise about everything in this account. What I can tell you is that it exists, that it has been measured, that the material specification that produces it was written with deliberate chemical precision by people who knew it would produce it, and that the supervising engineer who oversaw the program believed strongly enough in the importance of preserving that knowledge that he wrote it down privately when the official program ended. The frequency is in those lighthouses today. The Coast Guard maintains the structures. Ships navigate by the lights. And somewhere in the stone of each of those towers, in the mortar that Pleasanton's contractors mixed to a precision no one has satisfactorily explained, something is happening that has been happening since the structures were built. This is not a story about 14 lighthouses. The Pleasanton construction specifications applied to every lighthouse built under his administration. He administered 83 lighthouse constructions between 1820 and 1852. Not all of those structures survive. Not all of the surviving structures have been tested with a spectrum analyzer in the way Sievert tested his 14. The 14 are what we have data for. The pattern across those 14 is complete and consistent. Whether the pattern would hold across the full 83 surviving structures from the Pleistocene era is a question that has not been asked, in part because asking it systematically would require equipping preservation engineers with spectrum analyzers and a research protocol, which requires funding and institutional interest, neither of which has been applied to this question. What was lost when Stephen Pleasonton's administration ended in 1852 is not the frequency. The frequency is still there. What was lost is the knowledge of what the frequency was for, carried out of the official record by a supervising engineer who wrote one private letter to a stone contractor in 1849 and apparently wrote nothing else, and whose letter has been sitting in a sealed estate archive in Providence for more than 70 years, inaccessible to the researchers who might have known how to read it even if they had known to look. The mortar specification survives in the construction contracts. The contracts are in the National Archives. The frequency survives in the stone. Paul Sievert's field logs survive in his files. The letter survives in Providence. What does not survive is the chain between them, the explanation of what was designed, by whom, for what purpose, and what it was expected to do. If you know someone who has stood in a lighthouse, one of the old ones, one of the granite towers on the New England coast that have been standing since before the Civil War, and felt something in those walls that they could not account for, share this with them. The frequency is real. The field logs are real. The mortar analysis is real. The letter exists. 14 lighthouses, still operating, still generating something their builders put into them. The Coast Guard maintains the lights. The stone maintains the frequency. And somewhere off the New England coast, on a clear night, the ships that pass those towers are passing through something that has been there since 1831, and that nobody in the last 170 years has been able to name.